Well, welcome. In this video, we're going to be looking at how to multiply rational functions. But first, let's look at this simple problem where we have 4/5 and 5/6 being multiplied by each other. Now, in situations like this, we want to multiply the numerator and denominator separately. So we would multiply 4 by 5 to find the numerator of the product. And like I said, we would multiply the denominator separately. So we would multiply 5 by 6 to find the denominator. Which means 4 times 5 is 20 and 5 times 6 is 30. So we have a fraction of 20 over 30th. Now, we could simplify this, I know, pretty easily. But it's really important before we look at how to multiply rational functions to understand this concept of how to cancel out and the different factors from the numerator and the denominator. So instead of just jumping into this and reducing this to 2/3, which I know you guys would recognize to do, let's look at another way that we could factor this down, and that's by looking at the factors, or what we call the prime factors of 20 and the prime factors of 30. How do we get those? Well, we can use a factor tree. So over here, I'm going to do a factor tree for 20, meaning I can look for any two numbers that multiply together to be 20, like 2 and 10. Or 4 and 5. It really doesn't matter which factors you use. You'll end up with the same answer. Now 5 is a prime number, so I'm going to circle that one because the only numbers that would multiply together to give me 5 would be 1 in itself, 1 times 5. But 4, we can find two factors. We could find two numbers that multiply together to be 4, and that would be 2 times 2, and those are also prime. So the prime factors of 20 would be 2 times 2 times 5. Let's do the same thing for 30. So the prime factors of 30, again, we could use 3 times 10. We could use 2 times 15. We could do 5 times 6. Any of those would work. So let's say we use 2 and 15. And 15 then breaks down to be 3 times 5. And all of these numbers are prime. I circle them just to remind myself that I don't have to factor those down any further. So the prime factors of 30 would be 2 times 3 times 5. Meaning that if I multiplied 2 times 3 times 5, I'd get 30, just like 2 times 2 times 5 would give me 20. So if I wrote the numerator and denominator as their prime factors of 2 times 2 times 5 and 2 times 3 times 5, I could then cancel out any common factors between the numerator and the denominator. So the 2's would cancel out, the 5's would cancel out, leaving me with 2/3 as my answer. Well, what if we had a rational expression like this one, where we have x plus 1 times x, or x plus 1 over x minus 1 times a fraction 3 over 2 times x plus 1. Well, one way we could simplify this is we would do the first step that we did up above, multiply the numerators together, and multiply the denominators together. Now, when we do that, it really doesn't matter what order we have these factors in. All that matters is that we have them all listed. So now what we're going to do is we're going to cancel out any of them that are common between the numerator and denominator. Now, in the numerator, I have a 3, and the denominator, I have a 2. If that had been like 6 over 2, I'd want to reduce those numbers. But 3 over 2 can't reduce, so that's going to stay the way it is. But I do see that this factor of x plus 1 is common with this x plus 1, so they would cancel out. And there's nothing more I can simplify here. So my answer would be 3 over 2 times the quantity x minus 1. And that's my answer. So we're going to do that same process for some of these other examples. And remember, when we go to factor, we always want to start by looking for the greatest common factor first, or if there is one that exists. Now, when I look at those denominators, I can see that none of those have a common factor, a greatest common factor. But in the numerator, the 2x squared minus 6x minus 20, I can see that 2 goes into each of those terms evenly. So I'm going to start by factoring out that GCF of 2. And when I do that, I'm left with x squared minus 3x minus 10. Do you notice something about that fraction? Well, hopefully you notice that x squared minus 3x minus 10 in the numerator is also in the denominator. So right off at the beginning, those would end up canceling each other out. That worked out kind of nice. Well, we still have this other denominator of x squared minus 2x minus 8. And technically, we should factor that down, but there's really not a need to. Because I'll just tell you, if you were to use your Xbox method and factor that down, you'd end up getting x plus 2 times x minus 4. And if you notice, there's not going to be anything that's going to cancel out with the 3x squared or the 2 that we had in the other fraction. So we would just leave x plus 2 times x minus 4. Or we could leave it as x squared minus 2x minus 8. And that would be our answer. Let's look at another one that's a little bit more complicated. Let's look at this next one where we have x squared minus 8x in the numerator, 7x plus 35 in the other numerator, and then in the denominator you can see we have 14 times that quantity, and then we have x plus 8. Now 3 of these parts can be factored in some way. Do you notice which 3? Hopefully you notice that the x plus 8 is the only one that can't be factored. But the other 3 either have a greatest common factor or we could use the x box. For example, with x squared minus 8x, you always look to see, before we do anything, is there a greatest common factor? And yes, for this one there is. They both have an x. Same thing with the other numerator. They both have a 7 in common. Now the denominator, they've already factored out the 14, but the x squared plus 8x plus 15, that we want to check to see if we can use the Xbox method to factor that further. Now you should be familiar with that already. I am not going to go through it and talk you through it, but what I will do is I will show you on the screen, but I'll have it sped up so it won't go as, this video won't be as slow. So what I would recommend doing is pausing the video and hitting play when you're ready to check to see if you can factor that x squared plus 8x plus 15 properly on your own. But let me show you quickly how it's done. So as you can see, when you're finished here, this would end up factoring down to be x plus 5 times x plus 3. So my next step is I want to set these all up, multiply the numerators together, so I would have the 7 and the x in front, then x minus 8, then x plus 5. In the denominator, I would have 14 times x plus 5 times x plus 3, but then I don't want to forget about this x plus 8. So now we want to look to see what can be reduced. What can we cancel out? What are some common factors between the numerator and the denominator? Now the most obvious is that this x plus 5 and this x plus 5 would cancel out. Now this is an x plus 8, but this is an x minus 8, so they are not the same factor, so you can't cancel those out. And the 7/14, that reduces to 1/2. So if I write this out, I'd have 1x, or just x, times x minus 8 in the numerator. And the denominator, we'd have 2 times x plus 3 times x plus 8. Now we do want to simplify this. So what we're going to do in the numerator is we're going to distribute the x through. And when we do that, we would get x squared minus 8x. The denominator is a little bit more complicated. We're going to multiply these together, so we would have a box. We're not doing the Xbox method. We have the outside pieces, x plus 3 and x plus 8, that we have to multiply together. There we go. So this would end up being x squared, and this would be 3x, 8x, and 24x. So we would have 2 times x squared, 8x and 3x add together to be 11x plus 24. I would distribute the 2 through, so in reality, let me just erase this, we would have 2x squared, and remember this was 11x, so times 2 would be 22x. This was 24, but we're multiplying everything times 2, so that would be 48. So our answer would be x squared minus 8x over 2x squared plus 22x plus 48 as your final answer. Why don't you guys try the next two on your own? So let me just talk you through the process again. you want to look to see what can we factor from the numerator and denominator. So factor those first. Once you have them in factored form, multiply the numerator and denominators together, but leave them as factors. And then you want to cancel out any common factors between the numerator and denominator. Whatever's left over, you want to simplify in the numerator and denominator, and then you are done. So why don't you guys go ahead, pause the video, and hit play when you're ready to check to see if you have the correct answer. Okay, let's see how you did. Now if you notice with this one, x minus 8 cannot be factored. X squared minus 9 is, remember, a difference of two squares. So that's going to factor to be x plus 3 times x minus 3. In the denominator, 2x squared minus 18x has a common factor of 2x. So then we would have x minus 9. And they did not 2x times x minus 9 in that denominator. Now the other one, you need to use the Xbox method. So I will speed up the video like I did in the previous one. Okay, so you should factor that down to be x plus 3 times x minus 8. So let's look at what we have here. In the numerator, we have x plus 3 times x minus 3 times x minus 8. In the denominator, we would have the 2x. Again, these could be in any order. Then we would have x plus 3 times x minus 8. So now I want to look to see what do they have in common. What can we get rid of? X plus 3 and x plus 3, x minus 8 and x minus 8, and that's it. So in the numerator, I have x minus 3. In the denominator, I want to distribute this 2x through, so we would get 2x squared minus 18x. And that would be your answer. So let's look at the other one. So the other one is also a little simpler, because we don't have to use the Xbox method for any of these, but I do see that 3x minus 27, that has a GCF of 3. So we'd have 3 times x minus 9. So in the numerator, we'd have a 3 and an x minus 9. In the denominator, we would just have x minus 9 times x plus 1. The x minus 9 and x minus 9 cancel out, leaving us with 3x over x plus 1, which can't be simplified any further. Well, that is it for multiplying rational functions. But in the next video you watch, you'll be learning how to divide rational functions. So we will end this video here, and good luck as you work on the next video.